Alright, so here's what we got. Got this little rig up here to answer the question. With this slingshot, shooting these balls one at a time, which one goes faster and which one has the most power? Well, faster power, we need to know the weight, we need to know the speed, and I don't have a microwave sensor and any of that fancy stuff. So what I did is I took this walker here and hung these pieces of paper, and on the bottom of each paper I've got the end of a stereo earbud, right side and left side, on each. So the paper was hung at exactly 18 inches apart. You could do whatever you want. You can make it 10 feet. It doesn't matter as long as you know what it is exactly. I got it as exact as I could and converted it to meters. Anyway, you take that setup and you can download a sound recording program that'll record stereo. I used Audacity, which works in Windows, Linux, Mac, all that stuff, but you can use pretty much anything. And with Audacity, I converted the sampling rate to 96,000 hertz, so I get the most accuracy. And take that the recording here, and you can see that here, not good at this stuff, but here is the first piece of paper, and here's the second piece of paper. And what this is the sound wave of this piece, this impact hitting this microphone. And if you want to have some fun, you can look at that time frame difference, and you see that you have, you can calculate the speed of sound between the two, and whatever delays are in between. But what I did is I took my sampling rate here and found the length in samples. If we look down here, you can see the sampling rate is 1226. Samples is 1226, and you can get that right here. It defaults to this, I think, but I did this with samples because I want my samples. Once you've established the beginning of each wave and the distance in samples, or the time in samples, you take that, and we'll use the weight later, but here's the distance in meters. Here's the samples of 96,000 hertz. 96,000 samples, that's samplings per second. And what we do is we divide this samples count by this. That gives us the number of seconds that have elapsed in that time. So with that, we take our weight in kilograms, because grams isn't going to give us the number we want. We want kilograms. Everything's in metric here. Times 0.4572 divided by that number we got earlier for the time in seconds. Take that, divide it by 2. This is a basic Newtonian formula. We get our force, or kinetic energy rather, in joules. So you take the ball's weight, take the sampling rate, run it through this formula. Oh, I forgot, you gotta take this part and square it. But that'll give you the joules. So this was the 3/4 inch ball. Has that much kinetic energy coming from my slingshot. Yours might be better. And I was pleased with the 3/4 inch results. I'll probably use those most often for, destructive purposes, and everything else will just be for fun. And so there you have it. That's how you calculate the kinetic energy of a bearing flying from a slingshot.